Hello and welcome to NASENI Milestones, a program where we showcase science and technology development activities of the National Agency for Science and Engineering Infrastructure, NASENI, through its mono-mandate institutes. Today we will focus on Science Equipment Development Institute, MINA, established for the production of scientific equipment and school laboratory apparatus for physics, chemistry, mathematics, biology, introductory technology, and other related subjects taught in secondary schools. The operational personnel at SEDI MINA are also involved in reverse engineering, which enables reproduction of essential tools, machine, and spare parts for various machine types. Some specialize in woodworks, ceramics, and the manufacturing of glass products. We shall get to see the amazing works of these Nigerians in the course of the program. My name is Kirian Umayo. For now, let's get some vital information on the philosophy behind the establishment of the Institute. And our guest is the Executive Vice Chairman of National Agency for Science and Engineering Infrastructure, NASENI, Engineer Professor Mohammed Haruna.
Scientific Equipment Development Institute, MINA, and Scientific Equipment Development Institute, Enugu, are among the first generations and part the oldest of NASENI's institute. The mono mandates of both Enugu and MINA is in the area of development of science laboratory equipment to help demystify sciences, the teachings of basic sciences. We commence with doing production of primary school science equipment, things that our pupils are familiar in their environment, the natural environment, not to bring stories and books of the kind of science product that are in Europe. What is the sciences behind butterfly, between those things children are playing with at home? What can they do with bamboo? What is the biological analysis of things they apply, talking about the sound, the clapping of hands, to develop local equipment to make it easier and interesting? How about a lantern? What can make it quench? What can make the luminous in intensity or brightness? What can they do for it to work? All those things that are familiar local terrain. What are the sciences to develop interest in science? Then the success of that and the support of many organizations like initially African Union or OAU at that time, then UNESCO has made it possible, and then with the coming of universal basic education to make all this equipment available across the country. There is no state or local government in the country that has not received this in Nigeria. We advance and produce junior science equipment for secondary school learning, junior secondary school in particular. The products we make 100% with local content, cover all these practicals needed as contained in their curriculum, and move further to do that of senior secondary school. And with our partnership with De Lorenzo of Italy, feedback system of UK, SNAI of Brazil, we now produce science technical laboratory, not only for skill acquisition, but for tertiary institutions, the universities, the polytechnics, the colleges of education in all areas. And then got involved our mono-mandate institution to be producing some component on their areas of competence and specialization for the two scientific equipment institutions to do that, and continuously upgrading our equipment, modernizing, and then using the reality. Now we saw the need to develop online practicals, virtual practicals during the COVID-19. And today, these are used by many schools, television houses. The good thing about our scientific equipment is that you can do practical anywhere, mobile laboratories. You can carry, people can carry his handbag home, which contain all the kits he needs. He can do practicals at home. He can do homework. There is battery. Even if they don't have electricity, dry cells provide energy for at their own level and to a higher level at tertiary institution. We attach with solar module, solar panel, and you can generate electricity anywhere and be able to apply, because this is compulsory. One of the reasons why we have failure and dwindling quality in our products from tertiary institution is what we garbage in from primary school to secondary school. And we are challenged because we used to come across workers that they have excellent results, but the equipment they are supposed to be master on it, they have never seen it practically.
Now, the importance of scientific equipment and laboratory apparatus in teaching and learning cannot be overstated, as they allow students perform experiments rather than just read about them. According to Professor Haruna, it's more economical to patronize locally made scientific equipment to curb importation, as NASENI has qualified Nigerians at various development institutes who produce quality scientific equipment of all categories and also carry out research that can evolve sustainable technological system for the nation's scientific industries. Now, I take you to SEDI production departments. Heads of the various production units will take us through their operational process, and we'll start with the glass products manufacturing section.
This is glass and allied section. This is a glass blowing unit of glass and allied section. He is presently producing some part of glass pipette, bulb pipette. That's what he's producing. This is the material, the virgin material. So he will blow to the required size using special blowing techniques of that burner. And by experience he has, he will now get bulb pipette in this form. This is the production of test tube. It is the same techniques, but it's different shape. That's what this glass blowing bench. All of them are busy doing either pipette or test tube. There are several other glass products that we do. Glass measuring cylinder, pipette, beakers of different sizes. They already produced test tubes. This is the first stage of production of the glass wares. From here it goes to other stages like calibration, heat treatment, screen printing, and then packaging. This one is a distillation arm flax with arm. It's still in the initial stage. By the time it goes up to the 70%, you hook the other arm part of it. So basically what they are doing in this bench now is the distillation flax with arm, test tube glass product, and ball pipette. But there are several others, but this for today, this is what they are doing here. This is a heating device for heat treating the worked glass material, that is the product. Once it leaves the bench, you bring it to this heating device, the furnace, for heating it to a certain temperature just to harden it, so that by the time it goes to other sections for calibration, for screen printing. It will no longer break easily. This is a calibration and scaling section. Like I told you before, the first stage is you produce on the bench, take to the heating device to anneal it to a certain temperature, and then we come here to calibrate it.
This is what we refer to as calibrating stand. The stand is used to carry out graduation, particularly on glass apparatus. As you can see now, what this lady is doing, she's calibrating a product called ball pipette. And this ball pipette needs to be calibrated to ascertain the accuracy of the product. So we have to measure up to 25. From the calibrating stand there, we have to move to circle grading machine, where there is a lady here is going to mark the very point that was carried out from the calibrating stand here to make it permanent mark on that on the ball pipette here, so that anytime you are using ball, whether in the lab or in the school laboratory or manufacturing center, the mark will remain permanently on the product. Printing apparatus, or you call it machine also, the ink is already in which the product will be set from under the mesh. You apply your ink to the quantity that you needed, so that by the time you print on the glass apparatus, the printing will appear clearly and permanently on the product.
Now to the engineering unit. Here we have a machine section where parts of a Bunsen burner and other products are machined. These machines are for construction, drilling, milling, and other forms of treatment before the final products emerge.
So this is engineering section. We are right now in machining unit, machining section. You can see the machines we have. We have shaping machine, we have lathe machine, we have milling machine, we have welding unit, and you can see those who are welding on one of our machines that we are producing.
He's working on the part of the Bunsen burner, and the part he's machining now is called the base. That is what he's doing now. We have the complete set there, but what he is doing now is working on the base. Something like this. This one is still under machining. It has not reached the final stage yet. This man here is machining the brows and the milestone that we used to put on top of the linear expansion apparatus. So you can see he is doing machining. The other man here is working on the nozzle. This nozzle is also part of the Bunsen burner part of the Bunsen burner. This is the final stage. After a lot of machining, drilling. So this man here is working on the business mobile card. This one is still under construction. This is a milling machine. What he is doing now is doing a milling operation. He is trying to mill triangular glass prism. That's what he's working on. So from this shape, this is where he's going, something close to this.
Okay, this is a foundry section. You can see they are busy doing casting. What they are casting now is the base of Bunsen burner. They just casted the base here. You can see the mold, and you saw them pouring in the molten metal. After a while, it solidifies. They bring it out, and you bring out the product, and then trim up the excesses of the product. Here we produce plastic products. You can see the 10 liters aspirator bottle produced using one of the blow machines there. We also produce hangers. In fact, our hanger is the best. This is a material called plexiglass. You saw the guy there using a milling machine to put it to finish. You first cut it here using this bandsaw to size. So so that we don't waste material. Then after it has been cut here, you mill it there. You now polish it using this polishing machine. When you polish it, it looks this way. This is a prism. It's a triangular equilateral prism used for optics, experiments in physics. So this is one of the things we do in plastics, apart from production of aspirator bottles, measuring cylinders, beakers, plastic conical flasks, and hangers. This is electroplating section. Here we do finishing and final treatment of our products.
What we do here is finishing of metals, most importantly. And as I usually try to introduce, electroplating is the practical application of Faraday's laws of electrolysis. We try to finish some of the products they bring to us here. The section is divided into 3 units. We have pre-plating operations, plating itself, and post-plating. Now, pre-plating operations are done to remove traces of corrosion in case there is one from the metal we want to finish. And then, if there is an oil on it, we also do degreasing. After that, you activate the surface of the metal, and then you bring it to the plating bath. This is a typical plating bath. This bath you are seeing here is a zinc plating bath. You have 4 accessories. You have electrifier, anode, cathode, and electrolyte. As you can see, your metal you want to plate, you place it on the cathode. As you can see, we hang this here, while your anode, what you want to plate on the metal, is attached to anode, while you attach this one to cathode. And as you can see here, presently is already undergoing plating. The next process is you rinse it, then you take it for passivation, which is more like coloring. And that is what he's now doing. You stay for some minutes. Yes. Now, after that, you rinse it again. You now rinse it. After rinsing, you now take it for drying. This is the final point. Now, most of the products, this is the process they undergo. Now, after drying, you are expected to get a finished product, something like this, as you can see.
All the items are here packaged to protect them from being damaged before they get to the customers. The items being packed here include test tube, glass funnels, and other items for junior science kits. And for further information on the works of Scientific Equipment Development Institute, Mina, here is the Managing Director, Professor Mohammed Baba Ndaliman.
Mandate of SEDI as a mono-mandate institute is part of research and development. Research and development, production and reverse engineering with respect to various laboratory items, laboratory apparatus in the areas of basic sciences of physics, chemistry, mathematics, and even biology. We develop system of mass production of these items for various entrepreneurs to seed the technology of this development for mass production.
What is the concept of research and development behind the products at SEDI, Mina?
One of the concepts is, since we are talking of transfer of technology, is to reverse engineer some of these machines and equipment that are used in production of various science apparatus. And then also is also to come up with various ideas and various new concepts on development of the new apparatus or new equipment that could be used at various levels of education, and not even education, even in some industrial settings, as well as hospital equipment, as they affect our mandates.
Which of your products would you like to project within the next 24 months for commercialization?
As we are now, it's as if you know what is the plan that is in pipeline. This year, we have planned to see how we come up with this much talked about junior science kit that we popularly call GSK, so that we will see how it goes to various parts of the country. We have made a plan that right here we will, since we will make, what do you call it, a point to the entrepreneurs by coming up with production line such that we will be able to mass produce this. In fact, our new plan within this 12 months is to produce not less than 3,000 units of our junior science kits, so that it will go to various parts of the country. And we are doing that with the hope that by the time we are flooding the country with our product, those who are engaged in importing several others will look inward, either to take up the production process we are using or to patronize our product directly. This is one of the plans. So we are earmarking massive production of junior science kits in the coming few months.
Is there any synergy between SEDI, Mina, and other institutes under the National Agency for Science and Engineering Infrastructure?
We are collaborating a lot with our sister institute. For instance, it's only last week some of staff from Enugu left here, and we also used to send our staff because we share knowledge and we also share facilities. Again, there is this Karshi energy. We collaborate where they have comparative advantage, either in terms of infrastructure or in terms of knowledge. We work with them. Other institutes like Jalingo, Advanced Manufacturing Technology Institute, Jalingo, we collaborate with them. So there is a high level of synergy between our institute and most other NASENI institutes that we have in the country.
It is obvious that NASENI and its development centers have been in the vanguard of creating industrialization paths for the country through science, technology, and innovation. It is expected that the private sector could take it further by partnering with the agency for commercialization and mass production of NASENI products. And that's our program for today. My name is Kieran Umayo. Thank you for watching. I'll see you again next week.